pH is the measurement of hydrogen ions in a solution. Okay, so when you're measuring pH, the more acidic means that it has less hydrogen ions and more OH, hydroxide ions. And the more basic something is, it has less hydroxide ions and more hydrogen ions. This is the pH scale. The pH scale ranges from 0 to 14 and actually has the set of pH, which indicates how many hydrogen and hydroxide ions are in the water. And it tells you the concentration. So here's the pH scale, 0 to 14. And then it tells you how many hydrogen ions there are. It's 10 to the negative 100. And here's 10 to the negative 12. Okay, from 7 down is going to be acidic. And from 7 up to 14 is going to be basic, with neutral being in the middle. Increasing hydrogen towards acidic, increasing hydroxide ions toward basic. So, here are a couple things that I want for you to remember. The following statements may be made about the pH scale numbers. Increasing pH means that the ions, the hydrogen ions, are decreasing. Decreasing pH means hydrogen ions are increasing. Increasing pH means that hydroxide ions are increasing. Decreasing pH means OH, or hydroxide ions, are decreasing. So, the more pH, the less H. The less pH, the more H. And then for hydroxide, it's the higher the pH number, that means that there's more hydroxide ions. And the smaller number of pH means that there are less hydroxide ions. Okay, so how does that affect us? So maintaining homeostasis is very important, and it all comes back to that, especially when we're talking about our body and the systems around us. So the pH levels are checked in almost every aspect of biota, meaning like anywhere that we live, internally, externally, the water, any fluids, the pH is going to be checked, especially if something is needing to live there. So we know that the pH can affect our enzymes. Extreme pHs can denature. It also is used to measure the acidity of soil in agriculture, and it is also used to determine a safe range for fish to live, bacteria, any sort of shrimp, macro or microinvertebrates. They need to live in a nice range of pH. So when we talk about those extremophiles, like bacteria that live in extreme environments, they might be able to live in areas where the pH is higher or lower than a normal range. Okay, so these are household items that can affect nature, meaning like when we flush these down our toilets or throw them out the window or use them to wash our hair, they can affect the nature around us, like the soil and the water and the runoff that can lead to local water beds. So, increasing acidity, remember that's at 1, and then increasing alkalinity, which is hydroxide ions, is up to 14. If you see here, the battery acid, lemon juice, vinegar, and then we've got, milk and water, regular water should be here. Baking soda, then we've got seawater, milk of magnesia, ammonia, and lye, the extreme cleaning products. Okay, so let's look at adult fish. In pH ranges from like 3 to 4, adult fish can die. Okay, but from 4 to 5, that's where fish reproduction can be affected. And so normal can be in the range of 5 to 6, But acid rain, what we have to consider as acid rain, would be in the range of 5 to 1. We'll talk about acid rain in class, and also when we get into the environmental ecology lesson. But if you look, if we are releasing things like this into the environment, it could cause things to be a little more acidic. And there's also other factors that can make something a little more acidic. Okay, so water is actually, it's very useful for us, but it also can be very dangerous. And that is because the water can dissociate, meaning it can create some hydrogens that are free and available to form other acids like hydrochloric acid or sulfuric acid, and those are the things that are in acid rain. So if we think about it, if we've got chlorine floating around and our water dissociates, meaning the hydrogen, there's 2 hydrogen, 1 oxygen, that the hydrogen breaks free, then here we go. We have something that's much more dangerous than just regular water. Also, free radicals, those are atoms that aren't really paired with an electron. They can bond really easily to other things, and that's what's going to make a lot of problems with the release of any free radicals.